So the idea of today, is have the first part of is to finish the Python part, let's say, in our laptop. That we will finish with the plot9. We will see a little bit of matplotlib, how to work with a database, SQL, and also we will see two structures that they may be useful: the for loop and the if conditional. And also, we will see how to save a graph. Just 1 second. That I will. Okay, so I will. I need first to open Anaconda. I realize I should have opened it before, but well. Close here. As usual, many windows open. Right. So we need to open Anaconda and then Jupyter Lab. Okay, and this is open. Well, I think I can share. I can start sharing the screen. I think it's this one. Oops. So what I'm doing is I'm opening the. Well, actually, I think I can open a new one, maybe because yesterday one is quite notebook. I'll close this one. Yeah, we can start from scratch. So what I did if you use Jupyter Lab, you have on the left, you have a menu, and here you have you can open a new notebook or open an existing one. So let's just one moment. So for those that you have some issues with installing plot9, the way of installing this library of any other libraries, and let's remember how to do it. I think is if I manage to. Okay, here if I click in this button, this +1, I can open is this console? I can open a terminal, and here I can type pipe install plot9. In my case, because this is already installed, doesn't do anything, but in case that is not installed, this will get installed. I said yesterday that I tried with the Conda, but don't know why it didn't work, so I had to use pip. Anyway, later William will explain, because on ARCHER2 we will need to install some Python libraries, and he will explain how to do that. So yeah, the idea is with the pipe I should pip, sorry, not pipe, pip, or however. Okay, so let's start. The first thing that we should do is load pandas. So it should be import pandas as PD and load the plot9. Import plot9 as P9. We can also load the surveys complete. So we declare a variable called surveys complete, and we use pd.read data surveys.csv. And you remember yesterday we will get rid of the NA. So it's a drop NA. So if we execute that, should work. If not, let me know in the chat and we can see. Oops, something is wrong here. Okay, exactly. So if you see here, we have several. We execute several lines at the same time, but they tell us that the error is here in this line. Well, if you read the error, attribute errors at the module pandas has not attribute read, because it's a read underscore CSV. If we execute this again, okay, now it works. Cool. So there were two graphs that we didn't see yesterday. One of them is floating time series data. So one thing that we can get using Pandas is the yearly counts. So this is the number of count per year for each species. How we can do that? We will create a variable called yearly underscore count equal. So it's a surveys complete dot group by, and I will group by two different columns. I will use a list. So the first one will be year, and the second one will be species ID. I close the list and the bracket as well. I will make this maybe a little bit, yeah. And I will use for the count. Well, I remember that I need to use like one of the columns. So I will use, for instance, a species ID. Dot count. So I save that. And if I print a yearly count, I will get a list that for each year I get the species ID that I have counted in that year. I'm just checking because in the there is an option in the documentation that says that the result index and use name equal count, but I will let's check what it does. So with this, okay, the table looks different and add counts as a new column. So we can, in that case, we can use this table to do a graph. What I will do is I will save this and I will rewrite this variable yearly count equal reset index name count. And what I will do is I will plot this as I will generate a new plot. So if you remember from yesterday, because we are using, I think it's called, the way of doing these graphs is called grammar of graphics. That is like going like a step by step. So we will do that using plot 9. So it's a p9.ggplot. And you remember it's a data equal yearly count. And then I need the mapping. So the mapping is p9.as. And I need to specify here the x-axis and the y-axis. So x-axis will be here, and the y-axis will be, I think, yeah, count. If I can type, yeah. And I said before that it's like a step by step. This is like a grammar of graphics. Because now you need to do here we have like the, let's say, the layout, but we need to specify what we want to use in order to print the data. So we want to use a line. So it's a p9.geom underscore line. So if I execute that, let's see if that works. So it works, but it's not what we want, because, okay, the thing, if you see this graph, it's plotting for each year, plots all species ID together. The way of splitting them is to add, we have a specified mapping, we have a specified X, Y, but also we will need to specify the color that we want to use for each line. So if we specify here species underscore ID, the graph looks completely different. Here now we can see that for each species ID, the count every year. And as we learned yesterday, also we can change the x-axis label count And also even we can modify the legend of a species ID. So this is if in case that we want to use like a plot over time. So first we need to define the table that will look something like that. And then once that we have that table, we can use it to plot and generate this graph. I've seen a question in the chat in order to like use to save this figure, for instance. If we want to save it, we need to use a variable, for instance, called myplot, and I execute this again. Well, you see that there is no output because let's see that the output is saved here. I guess that if now I execute my plot, it will show the figure. And now what I can do is my underscore plot dot save. I will need to specify the name of the figure that I will call it, for instance, yearly dot png. I can specify the width that is equal, we will say 15 to make it the height of is 10, for instance, and the resolution PPI we will use 300. So if I execute that, well, this I get these warnings actually are like yeah, saving this image and also the file name yearly. So if you see here in the, you will see that we have this figure, and when I open it, it's quite big because the resolution is quite high. And you see like the level of detail that you can get using. So I see there is a question in the chat asking how to do lines more curvy instead of a sharp edge. That's a good. That's a good question. The thing is because we have the data that we have is let's see. Yeah, I'm not sure if it is possible because what I imagine that we have for this orange color, for instance, we have data here, we have data here, here. So we don't have the if let's say if we have data every year, the line will be like a smoother. But because I guess that we have data because it's yeah no. To be honest, for this one, rather than use like a line, I will use bars. I think that will look, it might look better. The problem is with the bars that to put all the species ID will be like a little bit of a mess. Also, we can try and see if the graph looks better using geometrical, no, geometrical, sorry, logarithmic. That was p9 dot. Let me check if I scale. X, Y is the it's also the thing that we can try and see how we can, rather than using my plot. Yeah, using a logarithmic scale doesn't look, I think it looks so worse, everything. But you see, for instance, here that we have a line that starts in after 1980. So I think it depends on the data that you have, because I think that, yeah, doesn't look quite. So yeah, I'm afraid that yeah, the graph is like looks like this one, but because we don't have like a we have I think from 1977 until 2002, so we don't have like all many years to make this smoother. Okay, so this is to see the over the years the counts. Just to finish this part, we will see how to plot, how to use faceting to. So to use faceting is, if you remember yesterday, we use this. Well, I will what's called p9.ggplot. Again, the data that we want to use, that will be surveys complete, and the mapping is p9.as. I specify the x, that will be weight. Y, that is the thing for the length. Color equal species ID. No, something is wrong here. Oh yeah, because I didn't close the class p9.geom point and alpha. Alpha equals 0.1 to make the point. Nothing is wrong, of course. Oh yeah, again, because I forgot to close this. So I get something like that. What if I want to differentiate of regarding sex? There is an easy way to do that. That is adding p9 dot facet wrap, and here you choose the column that would be sex. So if you do that, we'll make this a little bit smaller. You can get the graph, but you get two parts, one for female and one for male. As you can use, normally you can use this for any of the, yesterday, if you remember, we talked about categorical data, that is data that are in like in a certain classification, or let's say that you don't have infinitive choices, you have a few of them. So we can use with the with this, with the sex, and also we can use with the, for instance, plot ID. So if we use plot ID, it will take more time to generate the graph, but well, it works. So you see that for each plot ID, you get the graph. Also, there is an example in the documentation that that would be like worth having a look at that. The sample is because we can use this is the sample that we have seen before. So yeah, it's like one, let's say one small graph for each of the plot IDs, or one small graph for female and male. But also we can use what is called a phased grid. The following example is, for instance, we will compare female and male during 2000 and 2001. So to do that, we will create a new data frame that we will call surveys 2000 is equal surveys complete. And here I will select the years that are 2000 and 2001. The way of selecting that is, I write again, surveys complete. Okay, let's go step by step. If I want to select years 2000 and 2001, one way is first to do surveys complete. And I will select the column year. And that is a function that we didn't see yesterday that is called isIn. So this returns the list of values that, or the list of rows that meets the following criteria that are in 2000 and 2001. This is the list. So if I execute that, what I get is a list of false and true. If I use this one. So this is the list that we will use to get the rows in our survey that are from 2000 and 2001. So what I can do is just to make it more, this is like I can call it a Boolean list and survey 2000 to be equal to surveys complete. And to select, you remember yesterday that we can use the name of the columns, but also we can specify the list of true and false. If it's true, the row is included, and if it's false, it's not included. So here I specify Boolean list. We can do it like at the same time, but I'm doing like step by step in order that you can understand it. So here we are. And now if I print the survey 2000, we see that they get almost 3,000 rows, and I get from year 2000 until year 2001. I get all of these. And now the plot that I want to print, what I will do is I will copy and paste from here. It's better to do Ctrl+C, Ctrl+V. And what I need to change is data. So data now will be survey 2000. I want to print X weight, Y input length. The color will be the same. The on point will be the same. But here, rather than facet draw, I will use facet grid. And here I need to specify the grid that will be we will use the year, and we will need to use this. The notation here will be, I can make here a comment, will be rows. This I think is called tilde, columns. So for the rows, I will use year, tilde, and for columns, I will use sex. If I execute that, I get a grid that where I have columns are the sex and the years are the rows. So I get the 2000, 2001, May, and I can make some comparisons, so I can, yeah. So this is with the plot9, well, sorry, with the ggplot. This is only a small example of all of the graphs that we can do with this. Also another, okay, just to make this more complete, you may yeah, I will copy this in the chat in case that this is I should copy that in the Etherpad, but well. So just to recap what we are doing here, I don't know if this is possible to. We select from service complete, we selected the year that is in 2000 and 2001. And this returns a Boolean list of true and false. And to get the rows that are in 2000 and 2001, I use this list. This list contains if the year is not 2000 and 2001 is false, and if it's in 2000 and 2001 is true. So this is a way of filtering the list. Once that I have that, I get the same. That is, I'm thinking that is another way of getting the same list. Let me try and see, because remember that the list we have this another way that is coming to my mind is a user surveys, but surveys complete. And here we can use a Boolean expression, so we can use year is equal 2000, or let's see if that works, year is equal 2001. So if I execute that, it doesn't work. Because let's go step by step. Okay, so it doesn't work. I think I'm making here a silly mistake. I need to double check that. Maybe this is not allowed in Python. It should. Yeah, I'm pretty sure that there is another way of getting this list without using this, but I need to double check what is the way of. But well, I mean, also this is the way of let's say learning. Like try and see. This is also good when we use Python in this interactive mode, using a Jupyter notebook, or using a It's also possible to use, I think it's called IPython, or Python is like use Python in an interactive mode in order to get that. You see, like at the moment, you see that there is an error. I see that there is a suggestion in the chat. Okay, I will use that one. It's a service. Okay, yeah. Okay, that makes. I think well, it's not sounds like an excuse, but I think I would say that this is legal in R, so it works in R. But seems that my problem is that I don't know why, but sometimes I mix a lot Python and R. I would say that this is allowed in R, but okay, this sounds like an excuse. So yeah, executing that, for instance, yeah, it should work, and we get because when we execute that, we get a list of false, false, true. And I think, yeah, we can maybe combine. We'll see. Okay, so maybe the way is that one. Service year 2001. No, it's because I think it's a list. No, doesn't make that much sense. Okay, forget about it. So seems that okay. So if we are getting only 1 year, is this option could be used, but in case that we want to get more than 1 year, since that is easier if we use is in. Yeah, I think this option is like it might work in R, but I'm not, to be honest, I'm not pretty sure if that's a true statement or not. Okay, so just to finish with the plot 9 and to see, because yesterday we made a graph, the following graph. Actually, we'll copy that in the chat. It might make things easier. And you can copy and paste. So the graph that we made yesterday was we took data, service complete, and we used this here in order to get the count of. We execute that. You remember that yesterday the year was not that was not showing okay. So what we can do is we can that is one of the many ways of modifying the format is changing the angle of the year, the text, using like a 90 degrees angle. So we'll use that. Also, just to mention that my neighbor chose the best day to do some doing up his flat. So I hopefully you will not hear too much noise. But if you hear it, well, should be hopefully should be short. So I will type the what we will use in order to like to change this text and make it more readable. So is I want to change the axis text x is equal p9 dot element text, the angle will be 90. So if I execute that, you see that now the text is way more readable than before. Again, I'm insisting that you don't need to remember all of this. Actually, I don't. Let's see the lesson or the idea that you should take home today is that you have many possibilities with the graphs. So in case that, for instance, you wonder, okay, I want to change the orientation of the text, you can do. You can do show, and you can see if one works better than the other. So the idea of yesterday and today is to explain to you all of the possibilities, or well, a small part of the possibilities that you have with the ggplot or plot9, that is the Python library. Any questions so far? If you have any questions, please use the chat, but I will. Okay, so next one is I will use. We will see a little bit of matplotlib. Actually, when we use plot9 and when we use yesterday, you remember that from Pandas we were generating some plots. Behind the scenes is use matplotlib. Here, what I will show you are two examples. So one thing that I can do is I can take one of these exercises of yesterday. Sorry, yesterday of today. I think which one was the thing? Yeah, we use I can use this one, for instance, this example. Remove this. I mean, you can use any example that you want. What we are doing now is we will save this in a variable called myplot. Actually, I think I have that variable before. So we save it, and if in case that we want to edit the graph using a matplotlib, we can convert the output of a plot9 to a matplotlib object. That to do that, we need to create a new variable that could be my plot version equal my plot dot draw. So if I do that, I save this graph in a matplotlib version. And in case that I'm familiar with this, I'm familiar with that, I can. The thing is, yeah, I haven't explained with this. When this object, you can use matplotlib. For instance, the example that we will see today, is we can add a title. So what I need to get is because in Matplotlib we need to get the axis of this. Yeah, this sounds like a little bit. So to add the title, we need to use my Matplotlib version. So will be axis 0, because in theory, when you have a graph, you can have several plots, but you see that here we have only one, so we get the first one, that is a 0. And we can use a set title. Can say scalar plot, for instance. So if I do that, and now I do show. Oh no, it's not. So I think I need to do my so I need to use that. So you see the difference. Let's recap. This is in plot 9, and what I'm doing is I'm changing my plot 9 to a Matplotlib version. So using Matplotlib version, you can use the Matplotlib features. And one of the features to add, for instance, to add the title, you can use this line. And then when you print again, my Matplotlib version, you see you get the same graph, but you get with the same with the title added. And you can also use Matplotlib version of axis 0 set x label, that will be weight in grams. You can use the same for the y label, and say in the food len. If I execute that, you see that I can do changes to the. So it could be a little bit confusing, this axis 0. Here this is to refer, because in when you use Matplotlib, inside Matplotlib, you can have different graphs. So here I get the first one, and then I use set title, set x label, set y label. So you remember that also we can do this with the plot 9, but this is in case that you want to do it, or you want to use some features of Matplotlib. Okay, so this is regarding plotting. Do you have any questions? Let me have a look in the chat. I see that there is. I think it's everything. Yeah. So are we okay to move to? So let's start with the databases. Today I will not explain how to let's say how to work with a database in terms of modifying the database. What we will do is imagine that you get some data, and rather than the data is in a CSV file, we get the data in a database format, like in SQLite. SQLite, the well difference, not the difference, is like normally databases. If the databases you have a big database with several users, permissions, etc., you need a server. But SQLite, I'm not sure if advantage, but the feature of these type of databases that are saving a file. So you only need a file to get access to the database is saving a file rather than in a server. So having the file is like you have the database. If we go here in how it's called Jupyter Lab, and I move to data, where is the database? The database is this one. It's portal mammals.sqlite. So it's a file of almost a megabyte, and inside that file you have the database. So you don't need to connect to a server. Could be the case that you need to do that, and with Python is also possible. But what we will learn here is how to get access to this type of file. We have worked with the CSV files, but also we can work with the SQLite format. And the way of doing that is I will need the library SQLite 3. So it's import, I can type. Also I will paste in the chat the episode that I'm following. So first I need to load the library that I will use for the database. And I need to create, first of all, I need to create an SQL connection. If we are using a server, I will need to know the URL, maybe username, password, etc. But here, because it's a file, what I will do is I will connect to the file. SQLite3.connect. And the file, I need to specify here the relative path. So this is to connect to a database. And now once that I'm connected to the database, I need to get the, let's say, let's mention a cursor, but like a kind of a pointer, because when we read a database, let's say that we do it like when we read a book, like in order. So we get this, and we will like have a look. We will get it's like a kind of an iterator of this database. So the cursor will use my new variable that is called connection dot cursor, and I get let's say the pointer that will iterate through the database contents. And now what I will use I will use a for loop. What is the for loop is in order to iterate over elements. It could be elements of a list, or in this case I will use elements of this query that I will perform. So the syntax of the for loop is, well, the keyword for row. Row is the variable that I will use to iterate for row. I will minimize this. In, and I will do cursor dot execute. Here will be the SQL statement that I will explain now. This is very important. Never forget the column here at the end, and then you can you see that you get an indentation of 4 characters. I will print the row. Here we get the cursor. Iterate. Well, this is important. If you include everything that is indented is executing the for loop. But if it's not indented, it's like you break the for loop. You see that in other programming languages, you can use curly braces to set what is, let's say, the body of the for loop. But here we use tabs to do that. And now, once that we finish, don't forget to close the connection. That is connection close. So with this, for instance, we can do this if we write this in a Python script, we can execute it on ARCHER2, for instance, or any other machine or in your laptop. And that's it. Okay, next is the SQL statement. What we will do is we will use SQL syntax, but we will use like a basic. So what we need to, let's say, to get the whole table, we need to select all rows that is using a asterisk, and from is we need to specify the table name that is a species. And normally we finish the SQL query with a semicolon. So these are normally the keywords are written in capital letters. Select and from. Select is the row, sorry, I lied. I said the rows are the columns that they want. So I will select all columns from species. And what I will do with them, I will print them screen. Let's see if that works. I will execute everything. And you see that for each row, I get a tuple of I get the species ID. This is the G. Yeah, I get the 4 columns. I think. Well, this is a taxa. This is a genus, and I don't remember the. So this is a way, in case that for some reason, rather than having a CSV file, you have a SQL like file, or let's say, well, if you have a database, could be the case that the data is in a database rather than, and you get rather than a file that is in a somewhere else, but here you can specify the username, password, etc. What I said here that is the, if you specify species ID, I think you will get, you see, you get the this column. Also, you can select everything from a species where species ID is equal AD, for instance. I need to use this. So this is like a bit out, let's say, out of scope of this course, but here I'm showing you that you can use SQL to get what you want of the. But what if, for instance, let's say that you are not familiar with SQL, or you want to do it because what we are doing is we are opening the database, and we can do everything with the database because, let's say, we're using Python, and we don't need to use if we don't want SQL syntax. So what we can do is we can open the database, and we can create a Pandas data frame with the contents of the database. How we can do that? So we will need to use the Pandas library. What I will do is I will copy and paste this in a new. So this is the same. I need the connection. I will not iterate. So I will not. So here you see that it's like, let's say, well, still need SQL to get the, let's say, the whole table, but it's not a big. So here, what I will do is I will have a new data frame. Let's say database underscore data frame equal PD. So here I will need, it's already imported, but import pandas as PD. So data frame equal PD dot read SQL query. And here I specify select everything from survey. I will use a survey in this case. And here I need to specify the connection that I have for the database. So I have that, I execute that, and now we have this object. We have the database data frame that we can use it. So if we do, for instance, head, I get the, so now I open the database, was open, I connect the database, I extracted this table here, I close the connection because I don't need it more. And now with this, I can do whatever I want with the. So you see that here I have the whole table. So this is another way of working with. We have a pandas, but it's rather than using CSV file, we're using a SQLite file. So that gives us more ways to work with data. Not, I think also you can use other software to open or other ways to convert from SQLite to CSV. But for instance, knowing that using this SQLite 3 library, you don't need to. You just open the database, get the data that you are interested in, and that's it. There is a question in the chat that is if we can do the same, for instance, using NetCDF files. I don't know I don't know how, but I'm pretty sure that there is a library that where you can do that, and you can do so. And I said before, I think we can have a quick look at Google. If we netcdf, well, if I net Python, you have here, for instance, yes, so yeah, there is a library, seems that is called netcdf4 as NC, and here you have the file, nc.dataset, and you can that's the thing that that's the good thing of Python, that did I show no, I think I didn't. I think I searched it in another tab, and I didn't share the yeah, exactly. So thanks, William. I will yeah, I will move this here. So you see here, if we have a look, there is a library called netcdf4 that we can use to read the data that is in netcdf format. You see that that you have a for loop, and you can access the data, and you can so it's possible. And that's what I said at the yesterday at the beginning of the lesson, that the good thing of Python, that they contains many libraries that you can use. NetCDF, there is a question in the chat asking for NetCDF. NetCDF is a way of storing data on a file. This is like a quite, let's say, maybe a naive description, but it's a way of creating a file in order to store the data. That is HDF5, NetCDF, and these file formats, I think they have some features, because I think they follow some standards that could be used for if you, let's say, if you read the file using these standards, it's like a more because they follow a standard, they can be read by several programs, but not sure if, well, I guess that maybe well, this is like a naive description, but it's the idea is like a format, a file format. Yeah, thanks. That is in the. So yeah, one of the advantages that you can, for instance, these files, normally these files are big, and you can read them in or use them in parallel, and seems that yeah, the climate model data normally comes in netcdf format. I was recently working with in a project with the Met Office, and yes, we were working with the netcdf file formats. So yeah, cool. Okay, so let me check. So this is for the databases. For databases, what I will do is, well, I think we have finished. Let's say before finishing with this part of Python, I will explain the if, the structure if that we have in the. So this is a conditional. It's a call. So it's like we have, let's say, a number could be, or let's use a year 2020, and we can have if year is larger than 2000, int yeah, because I forgot the assignment. So this is like a pretty simple way of using an if. Is a if, I mean the structure is if and then a condition. If the condition is true, well, always finish with a column, and here again we have a indentation of 4 spaces. You can use the indentation as you want, but it depends on the standard. But I will say that like a 4 is fine. So well, in this case you print a 21st century, but also you can do else. That this is in case that this option is not true. You can print, let's say, not 21st century. We modify the year, we put 1995. You see that the output change. Also, you can say, well, this is not true, because if I put like the year 3000, it's the 21st century, and yeah, that's not true at all. But also here we can use if a year is greater than and the year is smaller than 2099, let's say, or what, 2100. Okay, now it works. So we compare year that is greater than 2000, and year should be smaller than 2100. And also you can have, so you can have several can have a similar, but using rather than 2000, let's see. Okay, let's include here, we will print yeah, this is a better, let's say 1985. So this is like the let's say the full syntax of you can have if, and here you have a condition. So let's I will use like a comment here, like would be if condition and do whatever you want. Then you can do elif. This is in case that this condition is false, goes here. Elif condition, and do an action. So here you can have several conditions. You can have like a condition 1, 2, 3. Let's say this is not kind of a pseudocode, so not And once that you finish with all of, if any of the conditions are true, you can use the keyword else and do another, let's say, one, just to be. Let's see that this is the syntax of. You can also like only use if, or use if else, or use several. So it depends on the case that. If we have time later today, we will see an exercise that depending on the, for instance, we will check the year, and depending on the year, we can generate a file or not. We will use the if that conditional in order to work with the data. So I think this is what I wanted to explain of Python, Pandas, plotting with plot9 and matplotlib, SQL. Do you have any questions about that? We have a break, morning break at 11, but before, not sure if, yeah, I mean, if you have any questions now, is things clear or anything that you want? There is a very interesting question that is like if there is any difference between using I think the answer, I will need to check. I will say that okay, the answer is for most of the cases no, there is no difference. But I think that, but I'm not sure if that is like entirely true, because I think, for instance, in this example, you see that I use. I think in this example is not true, because here I use this. Let's say that I don't know if it's called double quotation marks, but because here I need to use again these ones, I can use the single ones. Don't know if that makes sense. So if in case that I need to use it twice, I will need, let's say, that are more general using this quotation, the double ones. I know that maybe this is a little bit out of scope that for Bash is different, because in Bash, if we use a variable, let's say, this is not this is like not Python. This is like yeah, there is a difference, because if we execute this in Bash, we will get the content is home, but here you will get, oops, I don't know what I'm doing. For instance, if you use scripting in Bash, there is a difference, because when you use the double quotation marks, you can use environment variables and you can print the content. But when you use single quotation marks, you this is like, let's say, not you print literally what is inside that. This is what I remember my brain, but this, let's say there are some differences, but it's not. I see that there are some questions. The material will be. I see that there is a question about this material. The material is the material that we have used today and yesterday is from the carpentries. Is maintained by the carpentries. So this will be available. This will be available unless that I don't know major disruption or something get wrong. But normally that will be available. And also later today we will see other material that was generated by the PCC, actually by William, and this will be available as well. So all the material that is that we have used here will be available, and also the what else? The recordings from next week will be also available on YouTube. I see that there is a question. Yeah, okay, that's a good question. The semicolon here. This is regarding, okay, also there is a difference in when we use, let's say, programming languages. If we use, for instance, C, let's make, is this, okay. If I write something in C, that is like, for instance, a print, no, it's a print F. All of the, let's say, all lines or all sentences, let's say, you should finish them with a semicolon. Otherwise, it will be an error. You see that with Python, when we use Python, we don't need it to finish the lines with the semicolon because it's the way of that, like of writing code in Python. In C, for instance, you need to use a semicolon. But in SQL, when you are connected using a terminal, here because we use just a string. Here is kind of it's redundant to use a semicolon. But when we connect to a database, SQLite database, we will need to use a semicolon in order to write because when we are connected to the database, we can do imagine select everything from surveys where condition, and now you write the semicolon, and when you press, the query is done. Why is the semicolon? Because in that case, when you use the database, you can type several lines of the same query. So this is the difference. So yeah, thanks for the questions. Okay, so I think now we are in a morning break. It's half an hour. So now comes one interesting part of the course. So it's using ARCHER2 in order to see how it works, and we will play with the exercises. Okay, so let's have a morning break. Have whatever you want, coffee, tea, water, and see you at 11:30. I might be around, so if in case that you have any other questions, so please feel free to use the chat, and yeah, happy to chat. I will share this. Table.
Hi everyone, are you able to hear me?
Yes.
Perfect, thanks. It's just gone 11:30. So are you happy for me to take over from this point then, Juan?
Yeah, sure. Yeah, go ahead.
Perfect. Okay, thanks. Okay, great. So let me just quickly see if I can turn on my camera just so I can say hello properly before we start. And that doesn't seem to have done anything. There we go. Okay, I think that's on now. Okay, hi everyone. Hopefully you can see me now. Yes, so thanks to Juan for taking that bigger first part of the course. We went through methods for analyzing and visualizing data using Python. So I will be running the second part now, which is going to be the rest of today, where we will go through what ARCHER2 is, how to log on to ARCHER2, and set up Python, and then finally how to, and we will do this, we will try to run some of the exercises that we left ready for today from the first part of the course. We'll try to run those on ARCHER2. So there are a few things to go through. It'll just be, I'm hoping it'll be about an hour and a half. So we'll have an hour and a bit just now, maybe, before lunch, which will take for an hour. Maybe I should be sharing my screen. Yeah, let me do that. And then we'll go through the through the timetable. Hopefully you can see that. Let me just stop sharing my camera to save on bandwidth. Okay, so I'll bring over the timetable. So this is what we're hoping to do today. For the rest of today, let me make that a little bit bigger as well. Yeah, so just now we're going to start going over what ARCHER2 is and how to connect to it, a few bits and pieces about how it all goes together. And then the second session we'll have before lunch will just be covering how do we get Python set up for us to use. There are a few things that we have to do first before we can use Python the way that we've been using it on ARCHER2. Then we'll have an hour for lunch, then we'll come back and just do a little bit more preparation where we'll learn about how to run a Python script on the back end of ARCHER2. And this involves learning about the scheduler on ARCHER2. If you've used ARCHER2 or another cluster before, this might make complete sense to you and you'll be raring to go. But I think for a lot of people here, this will be completely new. So we just want to make sure that everyone's up to speed on this before we finally go into the last session, which is going to take up really the rest of the day until 5 o'clock we can go up to, where we will be putting together everything that we've covered to that point and running the exercises. We can read in these CSV files and data frames, manipulate them, and then make plots using Pandas and using Plot9. We can do all of that on ARCHER2 as a job. So that's going to be the big part at the end of the day. So this is what we're building up to. So let me just get going with this. I think there's a couple of images here perhaps I want to show first. So let me put the link to this in the chat in case anyone wants to bring this up. So you can follow that link that I've just put in the chat to get to this material, and you can click through these sessions to follow along if you like. Please, if you have a question, please either type it in the chat or as Juan said yesterday, we're quite a nice small group. So if you would prefer to just either raise your hand in Collaborate, or else just unmute yourself and ask a question, please go ahead and do so. And if you're having problems, both Juan and Rui are here today and they can both help you out. In particular, in the first session, the second session, we were sort of thinking about getting logged on to ARCHER2. That involves setting up an SSH connection, as it's called, to ARCHER2. If you've never done that before, there are some pitfalls. So if you're having problems with that, please don't stay silent about it. Please do ask for help, and they can help you. And during the lunch session, I'll also be available to help you get going in case there are any problems there for you. But with that said, let's get going. We'll try to follow this schedule. We might deviate from it a bit. We'll see how things go. So getting started, we're going to first of all ask the question, what is the ARCHER2 system? Because chances are that some of you may have never even heard of it before outside of signing up to this course. So if we're going to use it, learning what it is a good place to start. So if you were to ask, what is ARCHER2? This first sentence here is really kind of, I'll make that bigger again to make sure you can see it. This is really the one sentence answer to it. It's the UK's national supercomputer, essentially. So this is, I believe, still the largest supercomputer in the UK. It's what's called an HPE Cray-EX system, if you're interested. So it's made by HPE, that's Hewlett-Packard Enterprise, that used to be. And it's what's called a cluster. So supercomputers in modern times, if you aren't aware, are typically what we call clusters. That means that rather than one single computer, one single very fast computer, modern supercomputers are built up of many, many smaller computers which are linked together on a network. And we call those smaller parts, those smaller computers which make up the whole, nodes. So ARCHER2 is a supercomputer. It's a big supercomputer, and that means it's built up of lots of nodes, which are individual computers connected together over a network. And it's through those nodes working together that it's possible for users on the system to complete huge amounts of work, potentially. There are actually a good number of different types of nodes. Most of those users like us will never see, but there are three types of nodes that we really do want to think about here. Two of them in particular we're going to be thinking about today. The first type are the login nodes. I'll just scroll down and show you this picture. So this is a diagram of the ARCHER2 layout. It's funny that if you saw my cursor going large there, I don't know why it does that. Sometimes it just, goes up 10 times in size and then shrinks again. So there are the login nodes. So these are just small computers linked into the ARCHER2 system that make up part of the whole. So these are individual computers, if you like. They run Linux. All of the system runs Linux. So if you're used to the terminal through Mac OS or Linux itself, or if you're running Windows subsystem for Linux, you're probably quite used to this. And the login nodes are how users like us access and interact with a supercomputer like ARCHER2. So here we are with the people on the left, and then we use SSH, which stands for Secure Shell, which is a terminal that connects over a network, in this case the internet, to the ARCHER2 login nodes. Chances are, hopefully you've already had to go to do this. You've hopefully got your accounts for the course, and you've maybe had to go at logging in. in which case you would have logged into one of the login nodes. So these are how the users like us interact with the system. We can set up an SSH session, which gets us onto the system, and then we can get code in place. That can be Python scripts, it can be R, it can be Fortran, C, C++ code, maybe even something else if you've spent time setting things up. You can upload input data, and you can run simulations, or you can run data analysis scripts, which is what we're going to be trying to do. And then at the end of it all, you can download data back again to your system. Along with that, there are also the data analysis nodes. These are the nodes which we're really going to be looking at using today for the exercises. These are nodes which typically we won't be directly working on. We'll see how that works later on. But together with the Slurm batch system, as it's called, this is a scheduler. Again, we'll talk about this. They work with the compute nodes to essentially do work. So us as users log into the login nodes, set things up, and then the data analysis nodes and the compute nodes are going to do work, whether that's running potentially huge simulations of whatever, engineering, Earth simulation, chemistry, and then afterwards, maybe if we have data to process, we'll use the data analysis nodes. And then we again, interactively logged into the login nodes, are going to take that output, do whatever we want with it, download it again, and make plots, write papers, do whatever. Of course, these are just these are just the nodes. So these are computing resources, we can call them. So data analysis nodes and compute nodes, these are just computers with lots of processors. So in terms of processors, what they have are what they're called AMD EPYC Zen 2 7742 model processors. It's a bit of a mouthful, isn't it? But these are single chip processors, each of which has 64 cores, and each of those cores can run up to 2.25 gigahertz. That speed itself isn't particularly amazing. That's nothing special. What is special is that each of these processors have 64 cores. So if you think the laptops that we're probably all using at the moment have 2, 4, maybe 8 physical cores on them, physical CPU cores, one of these CPUs has 64 cores, which is a big upgrade there. Furthermore, all of the nodes are dual sockets. So they actually fit 2 CPUs onto each node. So each of these nodes, each of these computers that make up the whole of the supercomputing cluster has a total of 128 cores. That applies for all of these, the login nodes, the data analysis nodes, and the compute nodes. So however many nodes we have of each one of those nodes has 128 cores available to do work. So you can maybe begin to see now maybe why this is called a supercomputer. We're putting a lot of computing power onto each node. These nodes are connected to a, and Rue's just made a note in the chat. Yes, so 2.25 gigahertz is the base clock, but if you want, you can boost those up to 3.4 gigahertz, depending on circumstances, essentially. Thank you, Rui. And the nodes themselves, of course, have to have a place to store data that they produce and read any input. So we've got actually 3 different file systems. There's what's called the home file system, and then there's a work file system, and there's a solid state file system. I'll talk about those in a little bit. So connecting using SSH. There's a question in the chat. Are the nodes the same as than the cores in our machines? So no. You can think of a node as a physical individual computer, if you like. It has CPUs, and it has memory, and it has, through a not normal for our laptop, say, it has connection to storage. That means it can boot up, it will run an operating system, and if you want, you can get onto an individual node and run a bash shell, essentially, and do things there. So the node is an individual computer. It has a CPU, and the CPU has a number of cores. So in the back in, however many decades ago, a CPU, a central processing unit, had a single core, essentially. So it had the ability to run one set of instructions at any instant in time. It would then use some magic to get multiple things running, in our frame of reference simultaneously. But it's a single core CPU was the norm several decades ago. But over time, the tendency has been to produce CPUs, so chips, which have multiple physical cores on them. So when I say this is the CPU, and that CPU, of which there are two on each node, which is a computer, if you like, each of those provides 64 cores. So each node, so each computer that makes up part of the ARCHER2 system as a whole has 128 cores. So if you're running a single node, then you have access to essentially one small computer that makes part of the whole supercomputer, and that provides you with 128 compute cores. Okay, so moving on to logging in. So of course, this is how you log on. Hopefully you've all been able to do this. I'll just quickly move this off to the side. And you can see here's my terminal here, where I've already logged into ARCHER2. You get a welcome message when you do that. So with that login address, although this is small, let me make this bigger. You would have done something like the following. If you are on Mac OS or Linux to log in, you would have said SSH and then your username at login.archer2, if I can type, .uk, and then you would have probably had to do something to tell it where your SSH key is. There are more useful ways of doing this that make things a little simpler. So I would have done this myself, IDRSA, ARCHER2, and then I would have pressed enter, and that will have told SSH here that I want to log in. So I want to connect, to the ARCHER2 login address, so login.archer2.ac.uk, using my ARCHER2 username for this course, which is WLTA104. And then to help me get authenticated, I have to tell it as well that my SSH key, which you've hopefully all created and set up on the safe and added to your account, that my SSH private key is this file here. So tilde means it's in my home directory /.ssh, which is a hidden directory that exists in my home directory. Any directory beginning with a dot is hidden. And then inside that directory, my private key is called ID RSA ARCHER2. That's one way of doing it. You can set up easier ways of connecting. You can tell SSH how to find that key automatically. You can tell it how to get the host to connect to much more simply, but just starting out from the basics, that's what we would have done. And after going through that process and connecting, we would then end up with, let me resize this to make it more useful again. We would have ended up with this, where we are now logged in to ARCHER2. So this is me having just logged in. I haven't done anything. Here's the prompt. The prompt is interesting because it's changed from, if I scroll up, that was my prompt before. This is my prompt on my MacBook. I'm on a Mac machine, and I had, well, this is actually from Anaconda. Then my username on my Mac at my Mac's name, mbpwl, in my home directory. And after I logged in, I've now got this, my ARCHER2 username, WLTA104 at LN02, and then the path I'm in, tilde again is my home directory. What this bit here means, this LN02, that stands for login node 02. So if you remember, I'll bring the diagram across again. I said this is how users interact with ARCHER2. They use the SSH terminal, and that logs you in to the login nodes. And I've logged in to one of the login nodes. ARCHER2 has several, and I've ended up on login node 02. If you log in again, you might find LN03, LN04, and yeah. So there's a question says mine said LN03. Yes. So the system, I think it's essentially a round robin system. So when you connect to login.archer2.ac.uk, it will send one person to the first one, then the next person to the second one, and so on, and then just loop back around. So this is essentially a way of, so Hans just said that there are 4 login nodes, LN01, 02, 03, 04. This round robin allocation of users to each of them when you log in is just a way of very roughly making sure that you get the same number of people logged in to each of those 4 nodes, just to spread out the load of them essentially. So so you're on LN03, I'm on LN02. If anyone else is logged in at the moment, you might find that you're on one of those nodes, or you might find that you're on one of the others. Someone's on LN01, fantastic. Yes, so what we are is so anyone who is on LN02, we're actually on the same node. And what you can do is you can type W, and this actually shows you everyone who's logged into that same node. So here we can see everyone who's logged in at the moment to LN02. And what I will not see is anyone who's logged into LN01, 03, or 04, because those are separate machines. And if anyone on one of the other nodes types in W and presses enter, you won't see me. You won't see WLTA104 because we're on separate login nodes. However, although we're on physically different machines, physically different computers, they are still ARCHER2 login nodes. They're part of the same supercomputer, so we have access to the same resources and the same files. It doesn't matter which one of the login nodes we're on. We can ls, we can pwd, we can see the same files and work with the same files and do with the same thing. What I'm really just trying to say here is, although we're on different nodes, we're on the same system. So so we can still do the exact same work, we can do the exact same things. So just got a brief aside here. I'll just bring this over. So there's a small exercise here as well. Just we'll just spend literally we'll actually go through it together. So there is a password policy. When you were setting up your accounts, you might have run into this, but the idea is to make sure that the system remains secure. So as well as using that SSH key, everyone has to use a password as well. There isn't any getting around that. You have to use both the password and the SSH key. That's to make sure that basically only the right people can access the system. and that password policy is there to help protect it. And as we can see, it allows people to use short, complex passwords and also long, simple-looking passwords that are, strings of seemingly unrelated words. So it's just a very short exercise. I think we'll go through this together very quickly, just take a minute or two. So following this idea that, what makes a good password, we're saying anything which is easy to guess is obviously out. Anything which is short and complex is good, and anything which is long, made up of random words is also good. So just as a quick guess, maybe you want to just type in numbers in the chat or something. Who thinks that my password would be a good password? I think this is fairly obvious, isn't it? Everyone's saying no. Yeah, exactly. My password is probably one of the most awful choices possible, isn't it? Yeah, definitely my password is going to be right there at the top of someone who's trying to brute force hack their way in password one. Oh dear. What about rainbow llama jumping? Does anyone think that might be okay? 1, 2, 3, 4, 5. Yeah, that's possible. I'm not sure if that's worse or better than my password. Rainbow llama jumping. Someone says good. Okay. Maybe okay. Anyone else have any thoughts on whether rainbow llama jumping is good? Fine. Okay, yes. So rainbow llama jumping is probably okay. I personally might be tempted to throw another. No, that would be a bad one again, because that could be very easily guessed, perhaps. Yeah, that's a really good point, actually. Not what 3 words for your home address. Don't do that. Hadn't thought of that, but very good point. But yeah, I might be tempted to add another random word. So I don't know. Let's just think of something completely random, and I'm terrible at this. Aerial. I'm looking out of my window and I can see a TV aerial. So rainbow llama jumping aerial. Just string together random words. That becomes complex. It becomes unlikely that someone attacking the system would be able to just string together these words and brute force enter the system. What about option 3? This one here, A exclamation mark 94 UFSKL dollar question mark. Third password seems best. Good, reasonable. Yeah, again, I'd maybe make it longer. I personally tend to set mine at sort of 15 or 20-ish characters, and increasing the character set helps. If you add in symbols like dollars and ampersand and the like, that makes it more complex and harder to crack again. But you might forget it in the comments. But yes, so this is I use a password manager because there's no way I can remember these. So you can use something like one password or LastPass. Yeah, so this is why there's maybe there is a choice, I think. So rainbow llama jumping, you can picture it. You can picture a rainbow-colored llama jumping, and there we go. You've remembered the password. Number 3 looks more complex, but it is harder to remember, just using your memory. But both of those should be pretty good. Moving on to number 4, the last one. This one, have a think about it. What do you think about number 4? Is this a good password? You might this one is I would say this is perhaps a trick question, this one. Any thoughts? Same as 1 or 2, I don't know. Okay, anyone else? It depends. I think people are thinking about it. Okay, well, I'm going to drop down the solution here. If you haven't, better to mix case. That could be, yeah, okay, so we've got some interesting answers here. let's take a look at the solution. It does seem okay. So when I saw this myself the first time, I went, sure, that's perfectly fine. As it turns out, it isn't. And as I say, it's a little bit of a trick question. So I fell for this when I saw it. It's actually a pretty well-known password that's used on the internet. There is a, oops, didn't mean to close that. There is a popular webcomic that shall remain unnamed, but you can Google horse battery staple and you'll see exactly what it's referencing. I'll say that much. But there is a popular webcomic talking about this. Oh no, please put the link in the chat. I don't mind. It's from an XKCD comic. So this is a famous password, if you like, from an XKCD comic talking about using this type of password and how it's easy to remember. And because of that, it's probably on, you know, lists of passwords to try if you're brute forcing your way into a system. The Avengers End of Game probably, yeah, probably would be, well, no, it wouldn't be rejected because it does actually fit the policy, the password policy, but it's still probably a bad password to choose. Anything, any sequences of words that are easy to link together, anything, you know, famous, you know, if you did The Lord of the Rings, you know, that's an easy sequence of words to string together. It has to be something that isn't well known, seemingly random. Rainbow llama jumping. Aside from this here, there is probably no instance of rainbow llama jumping on the internet. I'll probably be proved wrong now, but that means that this is quite random. It should be secure. So, so I mean, okay, that's good. So I think we've talked about this fairly in depth. So I mean, this is in the context of us logging into ARCHER2, but to be completely honest, this probably applies everywhere on the internet for absolutely anything that you have an account for, whether it's a website or another cluster you might work with or another remote machine that you have access to. This probably applies. There is a definite difference between a good password and a bad password. With my password and 12345 probably being the worst, horse battery staple probably a little better, but I would say still bad. And these two in the middle, again, maybe they could be longer, but I think they're probably fine. So yeah, and if you do try to use passwords like number 3 here, I personally would really recommend using a password manager like LastPass or 1Password to store them so that you can have, you know, these complex passwords and make sure that they're unique to each system or website that you use, just to keep everything as secure as possible. We already talked about the SSH keys, so those are really as secure as can be anyway. You've probably already created them and added the public part of that key to your ARCHER2 account. The important thing just to remember here really is that SSH keys are secure mainly as long as you always ensure that the private key never leaves the system that you created it on. So for me here, working on a Mac, and any of you who use Linux, you would have created a private key, which is just called whatever its name was without an extension, and a public key with a .pub extension. Those of you who use Windows and use hopefully MobileXterm, but possibly PuTTY as well, you would have created a private key with a .ppk extension and a public key without one. So what's important is that the private key never leaves that system. If that is the case, that should, in theory, you know, as long as your system isn't hacked and the key stolen, say, that should remain secure. Adding the passphrase on top of that to unlock the key and let it be used, that's just another layer again of security. So I won't spend any more time there. You hopefully saw the information about that in the setup of the lesson. Otherwise, we've got documentation on it and the ARCHER2 website there. Very quickly, to move data, you would be using SCP or rsync. So, SCP and rsync are both protocols to transfer data. These will be these are command line tools that you use on the terminal. I'll probably show them being used later on during the lesson. These are what you'll probably be doing if you're using, again, Mac or Linux. If you're on Windows, you'll have MobileXterm hopefully set up. MobileXterm, I think, is quite nice because it gives you the SSH connection, and then it also gives you a GUI on the left-hand panel of the MobileXterm window, which shows you the file system on ARCHER2 or any other remote system which you're connected to, and you can essentially drag and drop to move data and directories back and forth between your machine and ARCHER2. There is grid. Oops, there's missing a D there. There is grid FTP also there if you have access to a remote facility with that. This is much more specialized, and this is not guaranteed at all that you'll have access to this. This is really dependent on your end, but some people do have, say, grid FTP storage, at their home university or the like. And again, we're going to have a few of these links. There's sort of, again, really too much, to cover here, but we provide links to the documentation if you want to read more about these. So let's just quickly go through some more details about ARCHER2 itself now that we're connected. So here, again, we're all logged in. We're all on the login nodes. We're all at username at ln01234. But the back end of ARCHER2 is where the work is done. So the majority of the back end is made up of the compute nodes. This is where people will be running large simulations, which maybe run in an hour, maybe run over several days, and run in that time on potentially huge numbers of cores. So ARCHER2 has the 4 login nodes. In contrast, there are nearly 6,000 compute nodes. And if you remember, we said that each of those compute nodes has 2 physical processors on it, and each of those processors gives 64 compute cores, which means each node has 128 cores. So over the entirety of the compute nodes on the ARCHER2 backend, we've got nearly 750,000 compute cores. And again, contrast that to our laptops, which have 2 or 4 or 8 perhaps, and you'll see the difference in compute power here. So, with this, I'm not sure of the numbers. At least last year, ARCHER2 was, I think, maybe Juan or Rui can correct me on this. I believe it was the 4th fastest CPU-only machine in the world, I believe. There are faster machines out there which are equipped with GPUs, but ARCHER2 is kept strictly on CPUs. But it was 22nd, I believe, in the world overall for what I'll call compute power. It's there are ways of benchmarking this using special software to actually tabulate this in the top 500 list. But in the top 500 list, it was listed as the 22nd fastest machine in the world last year. Yeah, and I think it was about the 4th fastest CPU-only machine. Yeah, so I've said there are nearly 6,000 compute nodes in total. there are some differences between them. The majority of those, 5,276 of those nodes, are what we call standard nodes, which have 256 gigabytes of memory each. And there are a further what we call high memory set of 584 high memory nodes, which have double that memory per node each. So remember what I was saying, these are all essentially individual computers, but what makes them a supercomputer is that they share a file system, so they can all work on the same data potentially, and that they're all linked together using a very high performance network provided by HP Cray, which is called a Cray slingshot network. Access to those nodes, well, we've logged in, we're on the login nodes. We're going to talk in one of the sessions after lunch about how we actually access them, how we actually access these nodes and use them. Because that's what's using this, that's what's using a supercomputer is really all about. It's about using the compute nodes to do work. Some of you might have also used Archer, which was the predecessor to ARCHER2. There's just some information here. You can see difference in that between them. I'll actually skip past that. The file systems are important. So you maybe remember at the top of this page, there was that diagram showing the layout of ARCHER2. I'll actually scroll back up to it quickly. So we've got a home file system, a work file system, a solid state file system, but how these are connected to the nodes isn't the same. So let's start off with the home file system. And in fact, I'm actually going to show you my terminal for this. So I'll move this off the page. So when you log in to ARCHER2, hopefully all of you are at the moment. If not, you can just follow what I'm doing here on screen. There's a question in the chat about getting the keys random art image. That means that you've just created the key. So what you need to do now is add that key to your account. So those two key files now exist. So you should have a key with the name that you gave just before the random art was created, and a key and that's the private key. Then another file with the same name but .pub at the end, and that's the public key. So what you need to do now is add that public key to your ARCHER2 account, and you should be able to follow the instructions. So I'll just quickly show actually. So there are instructions on doing that here on the main page. And yeah, and Juan's just said that he can help you if you need to. But if you need some textual instructions, I guess there are instructions here on the setup part of this website. That's detailed here. Okay, so I was going to show you the file system. So those of you who are logged in can follow along with this. Otherwise we can you can just watch me doing it. So here I am, and I've actually just run pwd, so you can see this. So P. Let me make that a little bit bigger again. Pwd stands for print working directory, if you aren't aware. So print working directory just means it's going to print to the terminal the current directory that we're in. And that's home TA104, TA104, WL TA104. That means that we're in the home file system. So the home file system starts with /home. It then goes into a directory named for our project. And of course, we all have a project for this course that's called TA104. Within that is another directory called the same thing again for that project, so TA104 once more, and within that directory is our own user home directory. So my username, as you can see, is WLTA104, and that means that my directory here is just called WLTA104. And if you you can move anywhere else, I'll just move into /home/TA104 because why not? Here I am somewhere else. whenever you want to get back home, you can always just CD and hit enter, and it will take you back to home. Remember that this little tilde here, because the path shows up in front of the prompt there, the little tilde refers to home. So the home file system is there on ARCHER2, and it's where we'll end up when we log in. It's not a huge file system. It's backed up, which is one thing. There are snapshots taken of it to allow us to grab important files if we accidentally lose them, but it isn't particularly big. What we tend to use for big work, if we have a lot of data to store, and if we want to ensure that we have what I'll call high performance access to that data, we would instead use the work file system. And the work file system is set up essentially in parallel to the home file system. And to get there, that means we can just go to the same path as our home directory, except we put /work at the beginning instead. So I'll go to cd/work/ta104/ta104/ and then my username. And if I press enter, you can see I end up there. And I can pwd that, and you can contrast, here was my home directory, which began with /home, and here's my work directory, which is exactly the same, except it begins with /work instead of /home. So there are some important differences. So as I say, the work file system is much bigger. It's what's called a cluster file system, which is a type of file system that's pretty commonly used on high performance computing systems like ARCHER2, because it lets you string together lots of servers containing disks, which provide both metadata storage and object storage, which is cluster talk for files and directories. And it provides high performance parallel access to that data. The end result is I can't remember actually how big the home file system is, but we've got about 15 petabytes of storage available on the entire system for the work file system. So these directories beginning /work, in total there's 14.5 petabytes of storage there for us to use. When I say us in that case, I mean every user of ARCHER2. Although it's the, let me start that again. The difference here is in terms of how you access them with jobs. So if you were to run a job on the compute node, we won't be doing that in the course today, but if you were to be running some large simulation, perhaps on the compute nodes, a problem people often run into the first time they use ARCHER2 is they find that they can't read their input data, perhaps. And that's because the home file system, so everything beginning /home, these directories are not mounted on the compute nodes. The compute nodes can really only work with the work file system. So if there's anything that you're doing with the compute nodes, it has to go and work. We'll be using the data analysis nodes, which are a bit special and set off to the side, and they do actually have access to both. But I think it's good practice for us to keep data in /work. So the way I'll be showing things is that we'll still be keeping all of our input data and scripts in my work directory, and I'll be showing you that today. There's also the solid state storage. So some people will find that that's useful. So this is essentially a bunch of solid state drives hooked up together for just over one petabyte of storage. Depending on what you're doing, that can be useful if you need the ability to read and write data very quickly. Again, that isn't important for us today, so I'll just give it a passing mention. What is of interest is the way that we share data. So, so at the moment, let me move back to my home directory, and I'll just create a directory and a file, and I'll call it example.dat. So if I ls here in my home directory, I've got a file here called example.dat, and I don't know, I'll just put something inside it actually. I'll just say hello, and anyone who wants to can read that. So here's my home directory, and I can easily output the contents of that using the cat command. So if I just write example.dat, so this is basically saying, take this file and dump its contents to the terminal. And if I run that, you'll see hello. If anyone else in the course just now wants to try doing this command exactly, I'll maybe copy it into the terminal, into the chat actually, so you can just copy and paste it because it's a little bit long, sorry. You should find that it doesn't work. You'll get an error saying that you can't read that file. And the reason for that is that, permission denied. And that's because on ARCHER2, every user's own directories, whether on home or work, are protected. So any other user is unable to read them. So you can't read what I have in my directories, and I can't read what's in your directories. The question then comes up, what happens if we want to share data with other people? And for that, we have shared directories. So we've actually got two different hierarchies here. I'm going to move up here. So now I'm no longer in my home directory. I'm in the /home/ta104/ta104 directory. And I can ls here. And what I see are the directories for all of us who've created accounts in this project. So there's a good few of us here. There I am. I can see some other names here I recognize. And then there's this shared directory. And if I go into the shared directory, well, it's what it says. Oops. And I can type things in here, and I can create files here and share them with you. This one here that exists in home ta104/ta104/shared, this is one of two shared directories that we have. This one is there for us to share data with other people in the same project. So this is for me to share data with all of you, and for you to share data with me and each other, but not with anyone else. So not with anyone else on ARCHER2 who doesn't have an account, who doesn't have an account in this project. That's unfortunate. But then we have another shares directory, which is in just /home/ta104. So you can see here we've just got ta104, which was where we were just now, and this shared directory. And if I cd into this shared directory, this is where we would place data to share with anyone else on ARCHER2. What you might still have to do after moving files or folders, whatever, into these directories still is to fix them with a chmod command. I'll actually show you. So what I've done, ready for us doing the exercises, I've actually put the input data on ARCHER2. So if I cd, I'm just going to do it this way. There are other ways to get to work, maybe a little quicker. You can set up an alias, or you can use another command I can show anyone if you're interested. If you go to your work directory, well, actually, we're just going here. We're going into the project shared directory. And there's a file here, a directory here called data. And I've set this up so that this contains So this contains everything for us to do the exercises. So you can copy this data directory into your own work directories if you like, or else later on, and I'll probably show both, we can just provide an absolute path to that. But to make sure that that was readable, I had to run a command. It should work already for you, but you have to run a chmod command to change that. And I just did chrx on that data directory. And that chmod command says that I'm going to recursively give that data directory and everything in it read permission and execute permission if it has it elsewhere to everyone in this group. That group being TA104. So all of you should have access to this. I'm just going to copy this into the chat again, just to make sure, you know, if you want, you can go there, you can take a look at what's in there. You can copy those if you like, those files to your own work directories, or you might just want to use this path directly in your Python scripts later on. Okay, I'm actually going to skip the rest of this lesson. So there's some more. If you're looking at the web page, there's some more there about the software that we have installed there, but I think that's not too important for us just now. I'm going to move on to the next session, which is about preparing Python for us to use on ARCHER2. I don't think this will actually take too long. For the sake of it, I'm just going to move back to my home directory again. So once we've logged in, there is a version of Python available on the system. So I said to someone earlier that I thought that there wasn't a Python 2 on here. It turns out that there is a Python 2 actually already installed on ARCHER2, which is terrifying because Python 2 is now deprecated and no one should be using it. But there is a version of Python 3 as well. So these are just, you know, installed as part of the operating system. I can just show you, if I do which Python 3, you'll see that that Python 3 is installed in /user/bit. So this is just part of the operating system. However, we do not want to use this Python 3, and the reason basically is that there is a much better version of Python already installed on the system. And that was provided by HP Cray, who are the ARCHER2 vendors, the company which actually built the system. So what we want to do is we want to use this special version of Cray Python, we'll call it. It's much easier to use because it's already got some of the important packages installed. For example, NumPy and Pandas are already there and waiting to be used. And if we wanted to, it also has things like MPI, 4Pi, and Dask installed, which let us run big jobs on the compute nodes, which using the special software on the system to give us access to the special bills of the software, which let us use the network essentially. We could just install Anaconda or Miniconda if we wanted to, and that is perfectly viable, but it wouldn't have access to those special system libraries, which make it more efficient to use. But anyway, let's just see about actually using it. So we make it available for use via a module system. Again, if you've used ARCHER2 or another cluster before, you've probably had some experience with this. If not, the module system looks like this. It's a command called module. And then for now, I'll just quickly show you what happens if I type module avail. That's short for module available. Most people just write module avail and press enter. And we're going to get, in a second, it's a little bit sluggish, isn't it? Okay, it took a little while to come. We're going to get a lot of output, and you can just scroll through this however you like. And what this is doing is it's listing lots of versions of lots of different software. So you can see some things here which you might recognize: ParaView, CMake, GNUplot, and then a lot of other. So other modules, these are called. So each of these is called a module, and it's basically a file which sits somewhere on the system and is a guide on how to make that piece of software available for us to use. But if I do module avail Cray Python, we should see that there are some Cray Python modules available. Now I just want to use one of these, so you can use the different ones if you want to delve into that. But for now, I'm just going to go as simple as possible, and I'm going to load the default version of Python here, which is marked with a D. Module load Cray Python, and that's going to load that version of Python. And if I now do which Python, you'll see I've now got a different Python coming up. And if I do Python -- version, you'll see I am indeed now getting Python 3.8.5, thankfully not that version of Python 2 which was on the system for some reason. So here we've got a good version of Python, and in fact I can even start the Python interpreter. So this is just one way of using Python, and I'll see that I've got some information here about the version, how it was built, and also that this was a Cray build, the system vendor. And I can just use this like a normal Python interpreter. I can text equals hello, and then do text hello. And to quit from that, you can press either Control D or run the quit function to bring you back out. So that's us using the version of Python that's installed with the system. This is the recommended one to use. However, we know, and we've kind of had some experience with this now, that we might need to do some setups. So we all had to install Plot9, didn't we? When we were setting that up, yesterday afternoon. And just as with when we were using Anaconda on our own laptops, on our own machines, Plot9 is not installed on ARCHER2 as part of the Cray Python module. I'll quickly actually show you this. So we do have access to some things. So we can, we can do import, we can do import pandas as PD. Great. We can, if we wanted to use NumPy, we haven't used NumPy directly in this course, but if you know about NumPy, you can just import NumPy, and you can, you can immediately do, we can do the same thing as before. PD.read CSV, and so on. We can do whatever we want to do, and we could go ahead with that. However, we are missing some things. We are definitely missing. We are definitely missing Plot9. So we need to install Plot9. If you want to try any of the SQLite 3, I believe that's also actually isn't. Let me see. I can't remember if it is or not. Let me check. Unless I've actually installed it. Okay, so it's there now, but I might have actually installed that myself since I can't remember. But either way, I'll show you how to install things just now. So what I actually will show, import Plot9 as P9. I think this is, yes. So here's our problem. If we wanted to use Plot9, it isn't set up. We have to install it. So if you remember what we did yesterday to install it, we just did pip install Plot9. That isn't going to work here on ARCHER2. And the reason is that if you do pip install Plot9, what it does is pip goes onto the internet, it grabs the Plot9 install files, it downloads them, and then it installs Plot9 into the location where Python is installed, along with everything else that's that Python currently has installed. If you look at where Python is installed, it's installed. Oh, well, I just said that SQLite 3. I did type it right. Yes, yeah, okay. Yeah, so SQLite 3 is installed by default, but plot9 certainly isn't. Yeah, so the reason why we can't just install plot9 with pip install plot9 is because Python, as we're using it, is the Cray Python install. I can run a command module list, remember? That's going to show Cray Python is one of the loaded modules, along with a bunch of others that we don't need to worry about just now. But Cray Python is installed. When I use Python, it's using this central install. So this is a central, as we call it, installation of Python. So when all of us on this course are logging on to ARCHER2 and doing module load Cray Python, and then we're hitting enter on that and running it, and then loading that module, we're all loading the same version of Python, the same files in the same place. Now imagine, if you like, that say one of you needed to use a very particular version of Pandas. I'm just making this up. Say one of you wanted to use a very particular version of Pandas. So you said, okay, I'm going to use pip to install that particular version of Pandas. At that point, if you were able to do that, everyone else on ARCHER2, every other user, and I think there was something like 4,000 people, I believe is the number using the system. Every one of them, if they module loaded Cray Python and then used Pandas, they would find themselves using the version of Pandas that you've just installed, which may not be good for them. And then it can get, it can get crazier and crazier. If everyone were able to install or uninstall whatever they liked into this module, into this Cray Python 3.8.5.0, none of us would have a clue which packages are installed at which versions, with which dependencies doing what, and it would be a real mess. So the way it works is that all of this software that you can see, if you run module avail, is not writable by regular users of the system. So all of this is unwritable to us. We can load these modules and we can read them, and we can use the executables. So we can, we have no issues reading the Python executable and running it. That isn't a problem. But what we can't do is we can't write to it, because it's got to be kept protected for all of the users on the system. So that means that pip install plot9 is not going to work. Pip install plot9 would write to the Cray Python install, and it might be that no one else wants it, or no one else wants it at that version, so we can't do that. So at the moment, it kind of looks like we're looking at a version of Python which we can't make any changes to. It's there, it's kept static for all users on the system, which is good in terms of making sure everyone is able to access and use it the way that they want, but it's not so good in terms of letting us, install anything else. Of course, there's a way around that, and that just means that we don't install to Python itself. We don't actually make any changes to the Python installation. What we're going to do instead is we're going to install Python, so we're going to install plot9 in user space instead. So that means that, if I do again, which Python, if we do a pip install of plot9, normally it would put them here in this system directory where we do not have write permission. But if we do a user install of plot9 instead, it will install the files for plot9 instead into our own directories, where we do, of course, have write permissions. Here I am in my home directory. I can create hello.txt. I can create, sample.dat, I can, write whatever I like in my own directories. And the same for my work directories. Just in case you're interested, this is how I like to change to my work directory. It's a little bit of coding going on there, I guess a little bit of bash foo, but that's how I like to go to my work directories. And I can make another directory. I'll call it example dir, and then I can go inside there and I can create, I can do whatever I want within my own directories. So I can install plot9 or any other Python package I need into my own directories. Yeah, so there we go. So how do we install plot9, or for that matter, any other pip package into my own directories? What we do is the following. We do pip install, and we just do something extra. We do pip install -- user plot9. And if we hit enter, and I wouldn't recommend that you do it, then you should be able to install plot9 into your own personal directories. So what we aren't going to do is that we are going to change it so that it doesn't install into home, because that's what this is going to do. It's going to write into the directory given by some environment variables, and that's going to put them into our home directory back here. Remember, one important thing I told you: if you're running on the compute nodes, then the home directories are not available. They aren't mounted because they aren't very high performance. What's the compute nodes that do the real heavy lifting of the cluster do have available are those are the work directories. So we want to tell pip specifically to install plot9 in our work directories here. That just means we need to set up some environment variables, and I'm just going to copy and paste these into the chat, and then you can copy and paste them the same into your terminals. You should do this after doing module load cray Python. So I'll actually put that up at the top too. Module load cray Python. And then you've got three export commands to run. And I'll show you those running just here. You'll see that in those commands I've put into the chat, it uses a username of a user. So you should just change this to whatever your username is. So I'm WLTA104. So what this is doing is it's saying use as the base for everything that Python is installing in user space, use this directory. So my work directory /work/TA104 /TA104 / my username /.local. I'll press enter. Okay. Then I've got two more commands to run, which you can copy and paste from the chat. We're now setting the path environment variable, which tells the bash shell where to look for any executables, and then we're running the Python and then we're setting the Python path environment variable as well. That's telling Python where it can look for packages, essentially. So at this point, we've got the cray module loaded, which we can just do if we just check Python version, or module. Again, I've got to type this properly. Yes, one's just pasted a better version. Yes, you can just use $user. If you check the value of $user, so that's just another environment variable, that will always just give you your username. Yes, so if you use the command ones just pasted, that also works. Oops, I didn't want my top coming up there. So At this point, everything should be set up, and we can now run the command to actually install. I think we actually need matplotlib as well. I think isn't installed. Yes, so we're going to do that. We'll just do pip install -- user, and I'll just list matplotlib and plot9. I believe a warning comes up here, but it doesn't actually matter too much for what we're doing just now. I think there are some version inconsistencies in there. If we do pip install, it will just go through everything. Yes, it tells us that we want to maybe consider doing that. However, we can't actually change the version of pip that's in there. So I think yes, so this is telling me that everything's already done because I did this last night. I installed matplotlib and plot9. But this is the final command that you want to run, and I'll just paste this into the chat as well, so you can copy and paste that. So what this does is pip install user matplotlib plot9 tells pip that we just want to install those two packages, matplotlib and plot9. -- user says don't install them with Python itself, install them in our own user directories, and then those three export commands that we ran said for our own user install directories for Python, use these directories here. And in fact, I said to do that in my work directory, and if I do ls-a, so A tells ls to show hidden files as well, hidden files and directories, I can see that there's an extra directory here now called local. And if I go into local, I can see some things. I can go into bin. I'll see, oh, there's some f2 pies here, pyft merge. Looks a bit like Python, doesn't it? If I go into share, man, there's some man pages, and if I go into lib, I'll see there's a Python 3.8 directory, site packages. So this is now, you can see numpy is here. We'll probably see plot9 there. There we go, plot9 is there, matplotlib is there. So this is now having installed the extra things that we needed into our own directories. And finally now, let me just go back down to my work directory. If I just start up Python one last time, we're running a little bit over, we'll go to lunch in just a second. I should now be able to do import plot9 as p9. Takes a minute to think about it, but that should now run without any issues. It really does take a while to think about it, doesn't it? It took a while to start to import on my own laptop, in fact. But there we go, it's returned, so we can now import plot9. It's installed, and we're ready to go with using plot9 on ARCHER2. So at this point, we've logged into ARCHER2. We've said we want to use this special version of Python, cray Python, by doing module load cray-python. We've then set those three environment variables, Python user base path and Python path, so that Bash knows that and anything Bash starts knows where to install things and where to look for things related to our new installs. And then we ran that pip install command, and it installed matplotlib and plot9 in our own directories. So we could, if we wanted, we could install anything else that pip has available using those commands. So this is all just setup work really in this lesson. If you aren't sure about any of this, please do ask. You can also follow, there's a link to the specific lesson on the website, just put in the chat. If you scroll down to the bottom, there's a section, actually better than that, I can provide a direct link. There's a section near the bottom adding the extra packages for this course, and that has all of the steps that you need to follow from logging in, from that initial login page through to getting matplotlib and plotline installed. So once that's done, you should be able to start Python, just using that Python to just start the interpreter, like so, and then do that, import plot9 as P9. That should work for you. If you don't, please do let us know. So I'll finish there. So it's just gone. Okay, so we've run we've run 5 minutes past the schedule. The scheduled end time for this lesson. So I guess we can. I think taking a full hour for lunch is for the best. So I guess we'll come back at 10 to 2 in the afternoon in an hour's time. But for now, we'll finish there. First thing we'll do after lunch, we'll go over actually accessing the back end of ARCHER2 using the nodes which actually do work. We'll be looking specifically at using the data analysis nodes, how we access those and do things on them. And then finally, we'll get on to doing the exercises on ARCHER2 using all of this setup that we've done. So I'll be away for just a minute to get some food, but then I'll be back. And if anyone has any questions, please do, throw them our way during this hour if you want, and we'll help you out however we can. Okay, so with that, let's finish. And yeah, we'll be back at 10 to 2. So, okay, we've got. Yeah, so yeah, when you run that pip install command, if you get a warning saying you're using this version, but this one's available, you might consider upgrading. Please don't worry about it. It's just a warning. There isn't anything that we can actually do about that. That's part of the Cray package install. Okay, yeah, so please do shout during this hour if you have any questions or problems. Otherwise, I'll see you all again at 10 to 2.